So, okay, so some motivation. So imagine you know nothing about wines, like me, and imagine so the labels really give you no information about which wine is better. So would you then buy the cheapest bottle in the store? Some of you may know what this is. It's a $2 chuck. Or imagine you know nothing at all about hotels in some foreign city. The descriptions are all in a language you can't read. Would you then just go with the cheapest one? They all seem the same to you. Is it irrational in a search engine, in addition to specifying some maximum price, to also specify a minimum price? Like Hotels.com, you can specify a minimum price. That seems a little bizarre, since wouldn't you prefer to pay less than pay more? Right, so kind of a standard quasi-linear utility model for, for people, for buyers, says, buyers have some private valuation V for some item, and the utility they have is the value they minus the price they pay. So if you buy one, you pay some amount, you get your total utility is the value for the item you have for the item minus the price you pay. And the rational buyer would then select the option of highest utility. You got several choices, different values on them, different prices. You would pick the item of highest utility, value minus price. So it would seem to suggest that, all things equal, you just go with the item of lowest price since you don't really know anything about them. Right, so why not? Okay, so why not? Well, one kind of the natural explanation is that you're kind of using price as a proxy for quality. You don't know about wines, but maybe the higher priced ones are better. Because if most other people are knowledgeable, then it ought to be the case. Maybe if other people know about wines, then the better ones will be more expensive, and so then perhaps price will be a good indicator. So in this work, what we try to do is give two things. One is a formal model for how quality affects a buyer's utility, and then analysis of how price and quality can be expected to relate to each other when the sellers behave optimally. Okay, so we're going to have a model, and then we're going to see what should the seller do, and then we'll see for the optimal seller, will in fact price and quality be related to each other? So is it then reasonable to kind of use price as a proxy for quality? Okay. We can also view this as advice to a seller who has to do sort of two things: set prices and qualities, and some advice on how they should do it. Okay, so let me give a basic model. So since I'm the only thing between you and dinner, all my examples will involve food. So imagine the value of a buyer for some product, like a slice of pizza, is a function of two things. One is their private, I'll call it desire, vis a buy, for pizza, and in general, so how much you want pizza, and the quality Q of the specific pizza that you're thinking about. Okay? So there's two things: how much you want pizza, that'll be your VI, and then the quality of the pizza, that'll be Q. Now, how do you measure quality? So we're going to measure quality just as the cost to produce it. Okay? So implicit here is an assumption that sellers are sort of all equal in ability. It's just, how high-end they choose to be. So does this pizza store choose to buy cheapo ingredients and make a bad quality pizza? Or do they, put in effort, buy expensive ingredients, hire somebody, who's really good at it, pay more and create a better product? So we'll just define quality to be the cost to make the thing. So more expensive things to make will by definition be higher quality. All right? And then now we need some assumption for how quality affects the value to you, the buyer. And for most of this work, I'm going to assume that the buyer's value is the geometric mean of their desire for pizza, their VI, and the quality of the good. And I'll try to motivate why this. I think this is a reasonable starting point. So the geometric mean of these two, so their value and the quality of the good. And also we look at general what are called Cobb-Douglas valuations that are just VI to the alpha times quality to the 1 minus alpha. Okay, so we're going to look at this kind of model. I'll argue why I think it's kind of reasonable, and then see what does that imply about how sellers should behave and what's going to happen with prices and quality. Okay. First, just a quick example, just to make sure we're on the same page. Right. So, quick example. right, and the values are going to come from some distribution. So what's different about people is different people want pizza different amounts. Right. Okay, so just an example. So just to clarify the notation here. So let's say a buyer has a desire of $10 for pizza in general, and let's say a pizzeria is selling slices of quality $2.50, so it costs them $2.50 to make it, at $4, okay? So just to be clear, the buyer's utility is a geometric mean. It's right. It's going to be square root of 25 minus the amount. So that's the value minus the amount they pay, which is $4. So they have a utility of $1 for getting the slice of pizza. Clear? Right? And the seller's profit is the $4 they're selling minus the $2.50 it costs them to make it, which is $1.50. Okay? So the seller makes $1.50. The buyer gets $1 worth of happiness from the pizza minus the amount they paid. Right? Okay, and the total surplus is the sum of the two, and the price goes away if you think about the total surplus, that's just changing hands, which is the sum of the two, which is the $2.50. Another way to think about it, right, is if you think of the total surplus, that would be your utility if you were buying the ingredients to make pizza at home. And if you just do a quick calculation, it's maximized at VI over 4. So your optimal thing would actually be to spend $2.50 on ingredients to make the pizza. That's what's going to be most worth it to you, given how much you like pizza in this model. Another way to think about this also is if your value is $10 for pizza, that means $10 is the most you'd be willing to pay for ingredients to make pizza. Okay, more than 10, like $11 is not worth it to you. Sure, it's a better pizza, but it's not worth the $11 to you. $10 is the most. Above then, the cost is more than your enjoyment. Okay, so that's just an example. Right, so let me just try to motivate a little bit why square root. I think this seems like a reasonable starting point. So first of all, other things you might do, like say value plus order equality, those don't really make sense. So depending on what's in the big O, if it's bigger or less than 1, the optimal seller would just set quality to 0 or quality to infinity. It kind of doesn't really sort of make sense. You can do logarithmic, and then it doesn't make sense either. And also, economic models of quality use something similar. So for instance, there's this nice paper of Shugan called Price-Quality Relationships. And so he has a much simpler setting. Well, he has two kinds of buyers, some who care only about price and some who care only about quality. And it's a little bit different setting. So the quality-sensitive buyers, it's not like they purchase or don't purchase. They purchase an amount. Now, their amount they purchase is linear in the quality level, but the cost to the seller is quadratic in the quality. So it's really the same. I mean, we're just calling the cost to the seller quality. So our quality is square root of their quality. So this model, there's no private VIs. All of the type 2 buyers are the same. They're all identical. Just two kinds of people. Whereas we're going to be considering people with private valuations that can choose to buy or not buy their pizza. Okay. So let's see what happens. So first of all, like what should a seller do? So let's think of the standard model that we might look in the auction literature. The standard model in, say, an auction or a pricing model would be there's some distribution over buyer valuations. So something like this. This is some distribution over buyer valuations. And then the seller, needs to set a price P on their goods, what they're selling, pizza. And so what they'll assume is the buyer will purchase if they get positive utility. So if their value is larger than the price. So if you're going to sell pizza at $4, then you'd get all the buyers whose value on the pizza is bigger than $4. And then what you need to do, the optimization, is just you want to set the price that maximizes the amount of money you make per slice of pizza you sell times, how many slices of pizza you sell, right? And that would be sort of the usual thing. And then you'd optimize this. It would depend on the distribution. Maybe the optimal price might be at this price here, in which case you make this much money, per slice times the integral of this slices sold, or maybe the optimal is up here, where you make a lot more per slice times the integral of this slices sold. You do that optimization. That's how you'd set the price, right? That would be the standard setting. So now what we want to do is it's the same thing. So now we have a distribution over desires. The seller needs to set a price and a quality. And we'll assume the buyer purchases if they have positive utility, so that the utility is more than the price they're paying. And now what does the seller want to do? Well, the seller now wants to do two things. Set price and quality to maximize what? So now this is how much money they're making per slice of pizza they sell. It's how much they're selling it minus the amount it costs to make it, times, how many slices they sell, right? So they have two things, and it's a two-dimensional optimization problem. And so this is the optimal P and Q are going to depend a lot on the distribution. Okay, but what can we say about what they look like? Okay? And in particular, will price be a good indicator of quality or not? Right, so one way to analyze this, so first of all, this is what we want to do. We want to maximize this. So if we just rewrite this, let's define the threshold tau to be p squared over q. We can rewrite this as maximizing p minus q times, just square both sides here. This is the probability v is greater than or equal to p squared over q, the tau, right? Now if you fix tau, imagine the birdie told you the optimal tau, then all we need to do is figure out, fixing tau, you want to maximize p minus q, because this quantity is now fixed, and someone told you what tau is. If we just want to maximize p minus q subject to this tau, okay, which is just this quantity here, and if you just solve for that, and then plug that back in, you'll get that whatever tau is, the optimal p is tau over 2, and the optimal q is tau over 4. Okay, you just plug in this, take the derivative, set to 0, you get this, plug that into there, you get this. So what's interesting is that tau is going to depend a lot on the distribution, but whatever that is, even though the specific P and Q depend on the distribution, the optimal seller is always going to set price to twice the quality. Okay, so under this model, the optimal thing for the seller to do, although how high-end you should make the pizza depends a lot on the buyers, you should always figure out a quality, double it, and that's what you're selling it for. Okay, so the optimal seller, no matter what the distribution of buyers is to mark up by 100%. Okay, so given that says in this model, price really is a good indicator for quality in the sense that given the price, the quality should be the price over 2. And you get something very similar for these other Cobb-Douglas valuations. Like in this case, you would get a markup of 200% because the buyers are caring less about quality. Okay, just some notes. This is all for the case of no competition. So a buyer purchases if their utility is greater than 0. But you can imagine, what if there's also, a burger, sandwich, Chinese place across the street, right? Now the world's a little more complicated. So now a buyer is only going to buy the pizza if the pizza is worth it more to the buyer than the utility they get from their favorite other option, because they could get a burger instead, right? So for any given buyer, you can really think of them as having both a value on the pizza and, this is the utility of the best of their alternative choices. So if they get a utility of $1.50 from the best of their alternative choices, they're only going to buy the pizza if they get more than $1.50 worth of utility from it. So now you can imagine it's a more complicated world with a distribution over these pairs. Each buyer has some value on pizza and some combination of values on the other things. But interestingly, what you can show is that in this case, even though the exact relation between price and quality depends on the distribution, it only gets closer. Okay, so before it was exactly a factor of 2. Now it'll be closer than a factor of 2. How much closer depends on the details of it, but it'll never be more than a factor of 2 off. So it only brings it closer together. That's not unexpected, because competition ought to squeeze the seller. Okay, but it shows up naturally here. All right, good. So now what about market equilibria? So I want to turn to a little bit different context. So Walrasian equilibria. So in the standard model, we've got a bunch of, let me say, unit demand buyers. These guys here. You got values. They have values on goods here. Okay, and then a Walrasian equilibrium is a set of prices on goods and an assignment of buyers to goods such that every buyer gets their preferred item at these prices. A. B, the unsold items have price 0. Right? C, it actually happens to maximize social welfare, so it's a maximum weighted matching. And it turns out, D, that can be found via a natural process of raising prices. Okay? So what happens with qualities? With qualities is, let's imagine every buyer, instead of having a value, has a desire. And now what we want is prices and qualities on goods and assignment of good to buyers. Can we get all of these things as well? Okay? And it turns out the answer is yes. One thing just to note here is that just achieving A and B is boring, because one equilibrium could be everything has quality 0 and you just assign people randomly. Because everything has quality 0, nobody cares, right? Everything is worthless, they're just pictures. No one cares what picture they get. but it doesn't maximize social welfare. Okay, so we really want to get these two and social welfare and do it via natural process. So let me just first give an argument for how you can do A, B, and C without a natural process, and then we'll make the process more natural. So here's an algorithm. It's not a natural process, but it'll get A and B and C. First, just solve for the social welfare maximizing assignment. So in particular, know that if buyer I is matched to item J, the optimal quality will be their desire for that thing over 4, giving a welfare of that thing over 4. So you can just solve for the maximum weighted matching using Vij over 4 as the weight on the edge ij. That will be the maximum social welfare assignment with those qualities of people to goods and the qualities they should have. Once we have that, fix those qualities for the matched items, set quality to 0 for the unmatched items, and now we're just reduce it to the previous problem. Now that we've fixed the qualities, we have a classic version of the problem, and now do that atonement process in the classic. Okay, so that'll actually give you, the first 3, but it's not really a natural process in itself. You can get a natural process. Okay, so one thing that doesn't work, but is the first thing you might try, is just assign quality to half the price and then try raising them as in the usual atonement process. Usually you start low, so instead of starting at 0, you got to start at 1 here because otherwise people have 0 value. So you can start at 1, so those are the prices, those are the qualities, and then if you have some good is over demanded, these 2 people want the burger, you double the price and the quality as well. This does not work, and the problem is that normally as prices go up, something becomes less utility. The utility goes down. But since qualities are going up with price, actually something can become more, the utility can actually go up before it goes down for something. So that doesn't work. Right, so it doesn't. Instead, what does work is you can have buyers bid on the right to control an item. So if buyers bid on the right to control, they know if they're bidding $3 for something, they will then have they're basically buying a cook, okay? For $3, they get a cook who will cook the thing at any quality they want as long as you pay for the ingredients. So you pay $3 for the cook, $2 for the ingredients, you've paid a total of 5, and you've got a good of quality 2, okay? So that's what they're thinking. So now you can do the usual atonement process starting at 0, and it turns out this is just, it's very much just like the standard atonement process, except with buyer-specific additive offsets. Because you're thinking your real price is not 0. It's 0 plus the amount you're going to pay for ingredients. And that's different from what someone else is going to pay for ingredients because they want the Chinese food in a different amount than you do. But nonetheless, the standard argument still works. Okay. So, right. So you can look at a single seller with multiple qualities. So you might choose to have a great pizza or a not very good pizza. One good option is to sell at all quality levels with price equal to twice quality. And if you do that, it turns out that you'll actually do pretty well, get almost full social welfare within a factor of 4 of the optimals if you knew the buyer's value in advance. We don't know if that's optimal. It's within a factor of 4 of optimal. And I guess I'm out of time, so we also have a model with locals and tourists where the locals know the qualities and the tourists don't, and you get sort of interesting behavior there, but you can look at it in the paper. Okay, so just to summarize, we propose a model where the value of a good to a buyer depends on the quality of the good. We have some results on the square root utilities, and some open questions, a better understanding of a mix of sophisticated and naive buyers, the optimal seller behavior for interacting goods, and the weakened assumptions on how quality impacts value. And that's dinner.